All right, so I finished my general announcements. Highlights, CFU number 4 is last day to retake it is tomorrow. Students received a review packet last class that we do this week on Wednesday. That is the only homework assignment in this class that's not collected on the first day of the week, but instead will be collected on the day of the test, which is Wednesday. Today, we're just going to be finishing the last pages in the packet. It's all review, so nothing new today. And tomorrow, students will be given work on their review packet and ask questions. Okay, but the bottom line is, you can do what we're going to do in class today, and you can do what's in that review packet that you're going to turn in on Wednesday. You can do everything that's on the test. Okay, so stop me and ask questions at any point today if you have one. Okay, so first question says, given f of x, find and plot f inverse of x on the second grid. Be sure to make a table for both graphs. Okay. All right, thank you to those that help contribute here. The first task is, can you read points off a grid? Can you plot points on a grid? Remember, you're always going left, right first. You're always going up second. Now, you're asked to plot the inverse. So remember, to create the inverse, and the directions say, be sure to make a table for both graphs. That's why I'm doing this. Remember, to build the inverse, all you have to do is flip the numbers. So the 0, 1, 2, 3, 4, 5, 6 becomes the second column now. And the second column, the 7, 2, negative 1, negative 2, negative 1, 2, 7, that flips to become the first column. And now it's a matter of plotting these points correctly. I'm going to wait a minute. Take a minute and plot these points, because if you cannot read points off a grid and you cannot plot points, you're basically going to have trouble with 90% of the material in this class. Okay? All right, folks, so if you graphed this correctly, you should have ended up with a parabola that was facing to the right instead of facing up. So you have the function on the left, you have the inverse graph on the right. Questions? All right, go ahead and turn the page. Again, it is on you to ask questions if you have them. Okay? Make sure you're taking notes to be able to be prepared for tomorrow's test, or Wednesday's test, excuse me. So this is a list of things that you need to be able to do. Okay, and this is the list of things we're going to go through today. Okay, now this one is actually really, really similar to, I think it's homework number 14. So number 14 is the last one that was assigned on Friday. It dealt with using slope. It says, Jackie, Patrice, and Nina play softball on the same team. The first base coach recorded their time and distance as they ran from home plate to first base. The results are on the graph to the right. Who is running the fastest on the time interval 0 to 1? Show how you determined your answer. So you're basically being asked to focus on a very specific part of this graph. You're being told to only focus on the graph that goes from 0 to 1. So this part right here, and that's it. Okay? Now it asks, who is running the fastest? Okay, now anytime you're looking at speed, we're talking about the steepness. We're talking about slope. So you would want to use this slope formula. I know this isn't written in your packet, but I will give this to you on your test on Wednesday. I'm not expecting you to have that formula memorized. I am expecting you to know how to use it. Okay? So what I'm going to do is I'm going to, for every single one of these people, whether we were talking about Jackie, who starts at 0, 0 and gets to, what is that, 1, 2, or if we're talking about Patrice, who starts at 0, 0 and ends up at 1, 4, or if we're talking about Nina, who starts at 0, 0 and ends up at 1, 1. Now, in every single one of these locations, hopefully you heard me say it as I read it off, they all start at 0, 0. They all start, in the context of the problem, at home base. 1 second later, you have Nina, who's traveled what looks like 1 foot. That's really slow, by the way. Jackie, who's traveled 2 feet, and then you've got Patrice, who's traveled 4 feet. Okay? That should really be like in tenths of a second, not full seconds, because I don't think somebody's going to run 1 foot in a second. That's pretty slow. But the point is, they all start at 0, 0. They each end at a different location. Nina ended at 1, 1, Jackie at 1, 2, and Patrice at 1, 4. So for every single one of them, we're going to have 0 for both x1 and y1. So for every single one of them, these values here are going to be 0. For every single one of them, we're subtracting 0, we're subtracting 0, because for every single one of them, they started at 0, 0. But the first numbers in that math, these numbers are going to be slightly different for all of them. Although they all have, notice, an x-coordinate of 1. They all have the exact same x2 coordinate. So for all of them, this number is going to be a 1. They all have x2 is 1, x2 is 1, x2 is 1. So really, we're repeating the same calculation over and over and over again, but the only number that changes is that first number in the numerator. So for Jackie, who I used orange, this number is going to be a 2. For Patrice, that I colored in purple, that number is going to be a 4. And for Nina, it's going to be a 1. So this is literally how you can calculate slope for each of these people. So for Nina, it's going to be 1 minus 0 over 1 minus 0, which is just 1 over 1. For Jackie, the only thing that's going to change is that very first number at the top. They all have minus 0, minus 0. They all have a 1 in the beginning, but the first number is the numbers that's going to change. For Jackie, it changes to a 2. For Patrice, it changes to a 4. And so what you end up with is Jackie has a slope of 2, Patrice has a slope of 4. And remember, we talked about last week how slope is literally measuring the steepness of a line. In this case, it's measuring kind of like how fast they're running, okay? So the steepness of a line is going to tell you the slope. And we're trying to figure out who's running the fastest. We want the biggest slope. So who is that? Nina, Jackie, or Patrice? Patrice. So the fact that Patrice has the largest slope is what tells you Patrice is running the fastest. Patrice ran the fastest. Her slope of 4 was the biggest. So this is an example of how we would apply slope, which is what we learned on the last couple days last week, to an actual problem. Now, the last question says, at what point in time have all 3 players run the same distance towards first base? You all can see that on the graph. This is literally testing your ability to read a graph. So at what time were they all the same distance? 2 seconds. You'll notice all 3 curves intersect and hit each other at 2 seconds. Now, it also says who runs the fastest from that point on. Now, we've already kind of established that steepness represents speed. So which of these 3 people, Jackie, Patrice, or Nina, and let's again realize we are now supposed to be focusing our attention on this section of the graph. At that point, who's running the fastest? Jackie, Patrice, or Nina? Jackie. If you notice, you've got this little diamond symbol up here. And by the way, the reason I use diamond, circle, square is because in your packets, it's not printed in color. So it wouldn't really help you if I colored them orange, purple, and green in the packet. It would print in black and white. Okay, but you can see that diamond at the top, that's Jackie. So they may have all been at the same location after 2 seconds. But after that point, Jackie is running the fastest, which is kind of funny because in the beginning, Jackie actually looked like, you know, Patrice was the one running faster than Jackie in the beginning. And that's kind of a reality. I think in the real world, there are plenty of times where one person might get ahead in the beginning, but then they get more tired, so the other person catches up and passes them. That's kind of what's happening here. Okay, but again, the reason I would explain I know it's Jackie running the fastest is the steepness of this line is greater than the other 2. So 2 seconds is when they were all equidistant. Jackie, because her slope is the most steep. All right, so I said before we're going to try to get through 5 pages today. We've already completed 2 of them. Turn the page, folks. Now for this one, I'm actually going to give a little bit of a hint, and this is really just for time purposes. We're going to now look at 2 graphs that are inverses of each other. Okay, and I say that because once we build the table for this one, we don't really need the calculator for the second one. We can get it right away. Okay, so I'm just trying to save us a little bit of time here by giving you that hint. Okay, this says accurately graph each function on its coordinate grid, then determine the key characteristics of each function listed to the side of the graph. So your ability to type an equation into the calculator is important. We want to type x plus 3 raised to the 3rd minus 1. So I would encourage you, get a calculator in hand and follow along with me. I'm going to type x plus 4 to the 3rd minus 1. Now, again, you never know what somebody else did with these calculators, so reset them. Second plus gets you to that reset menu, the memory menu, and then the so-called phone number you want to have memorized, 712. That resets the calculator to avoid anything somebody else might have done with it. Okay? Now, I'm going to go to y equals. this is where I'm going to type my equation. Okay, so I'm going to do parenthesis x plus 4, close parenthesis, and now I have to get the third power. Now, some people have differing opinions about how to get this. One option is to hit the math key, and you can see the third power right there. So that's one option. Okay, I could just go down to that third power and hit enter, and boom, it's there for me. Okay, my personal preference, though, is to take advantage of what's called a caret. It's this little miniature arrow underneath the clear button. If you do that, you're basically telling the calculator, I want you to bump up to that exponent position. And now the calculator is sitting there in a blank spot waiting for you to tell it what power you want. Now, you could put whatever number you want. You can put a 2 there. You could put a 3 there. You could put an 8 there. You can use whatever power you want. That's the thing I like about that button. Because if your preference, like I don't have a problem with it if a math teacher teaches you all, hit the math key, there's the third power. I have no problem with that. But I like using the caret more because then I can literally use any power I want, including 3. Now, don't forget to push over, okay, before you type the, what is it, +1 or -1? -1. Okay? In other words, your equation should not look like this. This would be a problem. That's wrong. That's a problem. Okay, because now the -1 is part of the exponent. It's not part of the rest of the equation. Okay, so the first line is good, second line is bad. Now, as always, I don't think it's a bad idea to look at the graph. You can kind of see what you're trying to graph. I can see some important stuff is occurring around maybe like -4 or 5. I'm not really sure what's going on there. But if I go to the table, you're going to immediately see none of these points are useful to us. They're all way too big. Remember, we need numbers that are less than 10. So if I keep going up, they're just getting bigger and bigger and bigger and bigger. That's not going to help me. Okay, so instead, I'm going to back up and try to find numbers that are smaller than 10, such as, that's a point that I could take, -2.7. Okay, so -2.7 is one of the values that I'm going to take here. Okay, it was actually the last one because I put them in order. I noticed when I backed up enough, I started at -6. I took -6, -9, -5, -2, -4, -1, and so on. Those are the values. I started at -6 and went all the way down to -2. These are the numbers that I actually copied. Now, here's what I'm going to do. I'm going to provide the graph and the characteristics. I'm going to challenge you all to do the second problem yourselves. Okay, this can't be just me doing the work in front of you all day. It has to be, some of the effort has to come from you all because you're trying to prepare for a test on Wednesday. Okay, now if I graph those points, this is the picture I get. I can see the point of symmetry right there. If I chop this thing right down the middle at -4, -1, I'm going to cut it into 2 equal halves. So that's the point of symmetry. I can see domain and range. Remember, domain is how far left and right a function goes. Range is how far up and down a function goes. Well, this function goes left and right forever. It goes up and down forever. So the domain and range are actually pretty straightforward. It's just every single number you can think of. It's got a part that goes up forever, down forever, left forever, right forever. Now, for the increasing, decreasing intervals, remember you're always looking at the function from left to right. So if I cover this thing up for just a minute, okay, and if I'm moving from the left side, I don't even see the function. I don't even see the function, but right now I'm hopping on the function. And imagine I'm riding my bike from left to right. Am I having to ride my bike up a hill or down a hill as I move to the right, folks? Up a hill or down a hill? I got both. So if you're on that blue curve right there, are you riding your bike up or down? You're going up. So this thing is always increasing. It is never decreasing. Okay? Now, I want to give you all, we'll say 3 minutes to work ahead of me. Remember, the hint I gave you is that this top function and the bottom function are inverses. So if you want to type this equation into your calculator and get the points, you can. But I would say it's way easier to just use the table we were already working with. Okay? Take 3 minutes. Try to create the new table, the new graph, and answer those features. Go. Call me over if you need help, folks. All right, so I gave students 3 minutes to work ahead of me on page 27 here. I gave the opportunity to ask questions. We're going to move to the next page now. Oh, that was there. There we go. All right, so top of page 28, it's going to be more practice with kind of the same idea. It says accurately graph each function on its coordinate grid, then determine the key characteristics. So again, this is a function I would fully expect you all to be able to type into your calculator correctly. We've got square root of x plus 5 plus 1. If I go to my calculator, and again, I had this old equation in, I'm going to reset my calculator. Second plus 712. I do that every single time, even if I'm the one using the calculator. I go to y equals. Now, the square root button, again, is underneath the x squared. So it's second x squared, x plus 5 plus 1. That is the equation we're looking for. Now, I'm going to show you two wrong ways to type this in. The first common wrong method that I see is people put both numbers inside the square root. That's not good. The other common error is kind of the opposite. You don't put either number in the square root. That's also no good. So the first one is what you want. The second and third ones, no good. Okay, the first one shows exactly how it's written on your paper. The 5 is in the square root, the 1 is not. Okay, so I'm going to clear those out. And if I go to my table, I'm looking for nice, clean, whole numbers. The other thing is, if you hit the graph, you'll see that it basically starts at -5. That's a useful thing to know, because now I know in the table, I can go back to -5. Anything before, it just says, what are you talking about? It says error. And that's because prior to -5, there's nothing there. It literally starts at -5, comma 1. And you can see that here in the table, -5, comma 1. In fact, that's your endpoint. -5, comma -1. That's where it starts. Okay. Now, from that location, it just shoots up and to the right the whole time. So before I even get the coordinate points, before I even start to copy values off this table, I can see what this thing is doing. I can see it starts at -5 and shoots to the right forever. It starts at +1 and it shoots up forever. And because it's always going up, starting at -5, it's always going up. So that's my increasing interval. And there is no decreasing interval. Notice I can literally complete that entire list of properties by just simply knowing how to use the calculator. Okay, now that being said, I haven't actually created the graph yet. So when you look back at this, I've got the point -5, 1, -4, 2, -1, 3. I've got 4, 4. I'm skipping all the ugly decimals. I'm getting the nice clean numbers. And if I keep going, all right, I can't technically get 11, 5 because 11 is a little bit off the grid, but it's only one number off the grid. Okay, so I put that point in green at the end of the arrowhead because I wouldn't really say you have to graph that one. But the other 4 you definitely can. You can graph -5, 1, -4, 2, -1, 3, and 4, 4. Those are the 4 points I would expect you to have. All right, last part on this page, and then we'll move to the final page of the day. It says use the given function to accurately graph its inverse. For this one, I'm going to be honest. I think I'll just include it in the notes in the video real quick because I want to save a good chunk of time on the last page. This is exactly like the very first problem we did earlier today. It's, can you look at a graph and get a few points? So I can look at this graph and I can see the points -5, 6, -4, 2, and so on. And create the inverse. All I do is take all those values and flip them. So I'm literally not going to give you time now to do this problem because it's so similar to the problem at the bottom of page 25. I'd rather reserve a good chunk of time. We got about 10 minutes. I want to reserve that time for the last page today. Okay? So again, if you're curious about this problem, and you're not sure if you're prepared to do it, look back at your notes and look at the problem on the bottom of page 25. They're basically the same. It's just different points. Okay? Turn the page, folks. So far, what we've looked at today is we've expressed the domain and range in interval notation. We've graphed square and square root functions. We graphed cube and cube root functions. We expressed features of those functions. We've graphed inverse functions. The only thing we haven't gotten to yet is this very last one. Okay, it says computing rates of change and using, oh wait, actually we did that as well. We did that as well. Now, there was one specific topic that had to do with inverse functions. And that was this page here. This was actually the one topic I selected to pull from the last unit. Okay, so this is actually the oldest material we're going to look at today, which is why I wanted to have like a good chunk of time to talk about this. Okay, so this is actually something we saw in the previous unit. It says compute the inverse of each of the following. The 4 steps you need to complete are as follows. So step 1 is meant to be an easy step. You change f of x to y. That's step 1. Step 2, you switch the position of the x and y. So you literally rewrite what you had before, but you flip the 2. Now, step 3 is we've got to get y totally by itself. Anyone recall how to do that here? Yep. We have to get rid of that negative 5. So we're going to add 5 to both sides. Now, how do we get the y by itself? Divide by? Not divide by y, because we want to keep the y there. We want to get rid of the 3. We're going to divide by 3. So if we divide both sides by 3, we get this. So it's a 2-step process to get that y by itself. And now that we've gotten y by itself, we're ready for the final step. Now, again, steps 1, 2, and 4, those are really supposed to be the easy steps. To me, step 3 is the complicated one. But changing f of x to y, that's not a big deal. Switching x with y, that's not a big deal. Step 3 takes some work, takes some understanding of how mathematics works. But once you're done with that, step 4 is change the y back in y inverse. So I literally just rewrite y inverse of x, and I copy what I already have, x plus 5 over 3. Okay, and this is the same process that we saw with several examples in the last unit. Okay, with this problem here, you would change f of x to y. You would switch the y with the x. And now your goal is to get y by itself. So somebody other than Izzy, help me out. What would you do here first to start getting y by itself? You would subtract 3. That gets you here. The opposite of adding 3 is subtracting 3. What's the opposite of squaring something? Square root. So we take the square root of both sides, we get here. You're done with step 3. Step 3 is get y itself. Okay? So now we're on to step 4, and step 4 is supposed to be the easiest. Replace y with f inverse of x and copy what you already have. I have square root of x minus 3. That is the equation. Okay? Take 2 minutes and try to do the next one yourselves. Try to do example C yourselves. In 2 minutes, I'll reveal the work. All right, folks. So again, step 1, replace f of x with y. Step 2, switch the x with the y. This is now a 3-step process to get the y by itself. The first thing I would do is multiply the 4 over to the other side. Now you can start getting rid of the other things. Now you can add 3 to both sides. Then you can divide both sides by 2. That's actually a 3-step one, so that's a little bit more difficult than the other 2 we looked at. But once you have y by itself, you're replacing y with f inverse. Okay? Now, bell's going to ring in about 2 minutes, so what I'm going to do is I want the video recording to be full, so I'm going to show my notes for the last one, but I would encourage you to give that an honest attempt yourselves, and then check the notes or check the video. Okay? But with that being said, we're done. Remember, your homework is work on the review packet. Tomorrow you'll be given time in class to work on that, and you'll have time to ask whatever questions you have. But if you can do what we did today in class, and you can do what's in the review packet, you can do what's on the test Wednesday. All right? Thanks for watching. Have a good one.